This is part 1 of a 2-part series where we'll explore and implement AI with the use of behavior trees. At some point you've probably wanted to make non-player controlled characters and may have come across this article by a Project Zomboid developer describing behavior trees and their applications. Though it seems shortened from when I first read it, it still contains good information and today we'll implement their example. The article is a good primer as I'm not going to go in depth about behavior trees, but rather, I'll be focusing on implementing it in Unity, specifically using Opsive's Behavior Designer. This is a paid asset, but there are other alternatives. Of course, it won't be exactly the same and you'll have to make up the differences yourself. In this video, we'll work towards this simple example in the article, where an NPC moves towards and enters a door. With that said, let's get started. From the package manager, I'll import 3 packages: Opsive's Behavior Designer, Gridbox Materials like I've done in the past, and Unity's NavMesh components. This isn't a visible package, so you'll have to import it by name as described in the documentation. Then I'll just move them into another folder, except for gizmos. This is a special folder that needs to be in the root of the assets folder. The scenario is an NPC trying to enter a building, so let's create the environment for that. I've made a door game object that contains an empty as a hinge and a mesh as a child of that hinge, as well as containing cylinders to represent the inside and outside positions of the door. I'll make this into a prefab and make a wall using the door, and then I'll make a building from that wall. Our AI will move using a NavMesh, so I'll create a new empty and add a NavMesh surface component to it. This is from the package we've imported earlier. I won't go into the specifics, but leaving it default will be fine. Collect all objects, use every layer, and render meshes as our geometry. We'll bake that, and with gizmos on, you can see the nav mesh in all the places an agent can go. You'll notice that they can't get into the building as the nav mesh is disconnected with the doors in the way. Going to the door, let's add a nav mesh modifier and check ignore from build, then apply it to the prefab to update all our doors. Baking again results in the meshes being connected, so agents can now traverse it. But obviously, we don't want that to always be the case. It should be connected when open and disconnected when closed. So we'll add a nav mesh obstacle, adjust the settings, and check carve. Checking carve cuts out the nav mesh, making the area untraversable instead of just something to avoid. Again, apply this to all the doors by applying it to the prefab. Next, we'll make a door component and make transform references for the hinge, mesh, inside, and outside position. We'll make a reference for the NavMesh obstacle, and don't forget the UnityEngine.ai namespace. I'll declare a bool to represent if the door is open or not, and a public property to access it. I'll add 2 vector3 properties to get the inside and outside positions, and lastly 2 static vector3s to represent the open and closed Euler angles of the hinge. Then, we'll create 2 public functions, one to open the door and one to close it. I'll make them return a bool, as knowing the success or a failure of an action is important for behavior trees. For now, they'll return true, but we'll expand on this later. Now, let's open the door prefab and set our references in the inspector. This part isn't necessary, but just to test the functions, I'll create a custom inspector and do it in the same file. Enclose using Unity Editor in the if Unity Editor directive. This tells the compiler to only include this code while we're in the Unity Editor. Without it, building will cause errors as it'll try to include the editor stuff in the game when it's normally excluded. Our custom editor will inherit from editor and will override the onInspector GUI. I'll leave the base onInspector GUI call as it will draw it normally, and underneath I'll get a reference to the door that we're inspecting. I'll do this by casting the target to comp door, and if somehow it's null, we'll early out. Then, we'll create 2 buttons, and if they're pressed, we'll call the respective functions. And don't forget, you have to give it the attribute of custom inspector with the type of comp door. Now back in the scene, we can open and close our door and see the nav mesh connects and disconnects. Next, we need our NPC, which will be represented by this capsule. Add a nav agent component, and again, we'll leave everything as is for our example. Then I'll add a behavior tree. This is how Opsive's Behavior Designer works, and we can open it up to get this editor window. Looking at our goal, these are the 4 actions that we need to make. I'll create a new folder to contain all the actions pertaining to our door, and create a new script called walk to door. This will inherit from action that comes from the behaviordesigner.runtime.task namespace. Let's declare 3 serialized fields, one for speed, stopping distance, and the door that we're moving towards. Then 3 more fields for old speed, old stopping distance, and the navmesh agent. When creating a new action in Behavior Designer, there are several functions that we can override. In this action, we'll override onAwake, onStart, onEnd, and onUpdate. OnAwake only gets called once, and we'll use it to get a reference to our nav agent using getComponent like you normally would in a mono behavior. OnStart gets called every time the tree enters the node, and will early out if we're missing either the nav agent or the door. We'll cache the nav agent's properties and set them to our new values, and then set the destination to the door's outside position. OnEnd will return the old values back to the nav agent. OnUpdate is where we determine the status of the action, whether it has succeeded, failed, or if it's still running. Again, we'll early out if we're missing references, but this time by returning failure. If the path is not pending, the nav agent is not on an off-mesh link, and it is within the stopping distance, that it has successfully walked to the door, otherwise it's still running. So you'll notice that there are a few problems with this script. It's very specific as it moves to the outside position of the door, and it doesn't take into account if the destination is unreachable. You may want to create a more generic walk action and supply it with a destination, but I'll continue following the example. Back in the editor, let's add that action, inspect the node, and we'll set the speed, stopping distance, and give it a door. In the scene, let's play, and we see that it works and our agent walks to the door. Now, with walk to door done, we have to do open door. Create a new script, add the namespace, inherit from action, and create a serialized field for a door. Then we'll override the onUpdate and give the same warning as before. Next, we'll call the door's open function. If you remember, it returns a boolean, so we'll return success if it's true and failure if it's false. Back in the behavior tree, we'll add the new action as well as a sequence to connect them. Then we have to set the reference and make sure it's the same door as the other node. Testing, and we see that our agent opens the door after they walk to it. If you haven't picked up on it, making sure that we always have the same references between the nodes is an issue, so before moving on, I'd like to fix this. Even though they're part of the same tree, the leaf nodes are quite independent from one another. Normally, in a behavior tree, there's a blackboard that holds all the data that is shared between them. In Behavior Designer, it uses Opsive's shared variable system, which acts similarly to a blackboard. To start, I'll make a new folder for shared variables, and in the dropdown, I'll select Behavior Designer, Shared Variable, and make a shared door. Open that up, and in the template, I'll remove the door class as we already have our door component. Then, I'll replace the instances of door with comp door, and that's it. Going back to our walk to door and open door actions, instead of a comp door reference, it'll be a shared door reference. Additionally, wherever we call door, we'll call door.value to get the value of the shared variable. If we inspect walk to door, we can still reference a door like we've done before, or we can change it to reference a shared variable. In the Variables tab, I'll add a new door variable and reference that in our 2 nodes. On our agent, we can see the new variable appears, and I'll set its value. Now both our nodes reference the variable, which we can change in one spot. Testing, everything works like it did before. Next up is walk through door. Since it's very similar to walk to door, I'll just copy and paste it over. In the onStart, I'll compare the distance of the game object to both door positions, and save the further position into a vector 3. Then, I'll set the agent's destination to the farther position. This action assumes that the agent is already at one of the door positions, otherwise it may give us the wrong side of the door. Again, this is very specific, and we could make both this action and walk to door a more generic walk action that takes in a position that's decided externally. But anyways, let's add the node and set its values. Here, if you want to make the speed and stopping distance shared, you can. Testing again, everything is looking good. Our fourth node is close door, so we'll create a new action, copy and paste open door, and change the function call from open to close. Add that to our behavior tree, set the door reference, and connect it to the sequence. Play, and I see that it closes the door on itself, so I'll just set the stopping distance to 0. And there you go, we have our entering door behavior. This marks the completion of the example as well as this video. However, this behavior really only works well as a single behavior in a larger behavior tree. It's not bad, but on its own it's rather useless. But don't fear, in the next video we'll expand this example and continue growing our tree. I hope that you enjoyed and maybe you learned a thing or two. Stay tuned and I'll see you in the next one.